We're going to have a look here at an idea, at a concept known as the difference of two squares. It's a really important idea, the difference of two squares, and one that you'll see a lot as you advance in maths, and one that it's really useful to become familiar at spotting. Let's have a look at this first expression that I've written up here. Bracket a minus b multiplied by bracket a plus b. I'm going to just expand this. I'm going to use the FOIL method. So a multiplied by a is going to give me a squared, and a multiplied by b is going to give me plus ab. And inside terms, minus b times by a is going to give us minus ab. And then our last terms, minus b times by b is going to give me minus b squared. So there we go, I've expanded that. I'm just going to tidy it up a little bit here. If we notice in the middle, we've got plus ab minus ab. Now, of course, those are just going to cancel each other out. So we can strike those ones out. What we're left with when we tidy up is a squared minus b squared. And you'll see here, this is why this idea is known as the difference of two squares, because we've got two square numbers, a squared, b squared, and we are finding the difference of those squares. We're subtracting. So whenever you see a squared minus b squared, you know that you're looking at the difference of two squares, and you know that the expansion is a minus b times a plus b. Now that's the formula that it is useful for you to know and to get familiar with spotting. Because when you see an example like this one, you could go through all this expansion, or knowing the difference of two squares, you could just think, right, I've got here one term minus another multiplied by the same two terms, but a sum. I've got a difference and a sum, just like I've got here. So actually, using this formula, I can just say, right, a squared, looking at the first term, squared, so I'm looking at 3t, and I need to square that, which is going to give me 9t squared, subtracted by b squared. b in this case is 4y. So if I square that, I'm going to get 16y squared. And that's it done. How much faster is that than actually doing the full expansion? That's the difference of two squares. Now, the other thing that you will need to do is to be able to go the other way. And you can use difference of two squares to factorize. Let's have a look at this. This is in the form already of a squared minus b squared, because we've got two square numbers. We've got x squared. We're subtracting 25, which is 5 squared. So we know we've got the difference of two squares here, which means we can go straight to our formula again, and we can expand that to x minus 5 multiplied by, remember our term here is 5 squared, x plus 5. And there's our difference of two squares. I've got a final example down here. Can we use the difference of two squares here? Do we have two square numbers and we're subtracting one from the other? We don't. We have 2y squared minus 18. Neither of those look like nice, neat square numbers to me. But notice we do have a common factor. We've got a common factor of 2. So let's take that common factor out first. 2 goes into 2y squared times y squared, and 2 goes into the 18 9 times. 2y squared minus 9. You look inside the bracket, we do now have a square number and another square number and a subtraction. So we're dealing with the difference of two squares. So we can expand that using this. Y squared minus 9 is going to give us y minus 9 is 3 squared multiplied by y plus 3. So here we're using the difference of two squares to expand and to factorize. And as I say, very, very useful to start getting used to spotting these.
Okay, Mary, so let's have a look at this one. So solve x plus 2x equals 12. So what do you think you do first?
Okay, well, I want x on its own, so I would put x equals 12 minus 2x.
Okay, so a lot of the time we want to get x by itself, but what we want to do first is get all of these x's together. So can you see anything we can do with this? Get all these together in one place.
Oh, okay, it's 3x, isn't it?
Yeah,
so
absolutely.
3x equals 12. Oh, and so x equals 4.
Brilliant, spot on, well done.